Okay, this is section 9.2, multiplying and dividing rational expressions. Skipped one, didn't I? There we are. Okay, today we're talking about multiplying and dividing rational expressions, which is the same procedure as multiplying and dividing fractions. So we're going to go over how to do it with fractions. All right, when I multiply straight across. But understand that it's going to be easier to go multiply straight across if I simplify. Notice 12 is 3 times 4. So the 4's can cross out. And I've got 9 over 7. On this second one, the 9 is 3 times 3. So one of the 3's crosses out. And this x is going to cross out, and we get rid of that new exponent. 2 times 3 is 6, so we have 6x over. The only thing left, well, I've got 3 times... Oh, sorry, the 3 wasn't there anymore. I apologize. This 3 is gone. So it's actually 2x over 3... times 5, which is 15. Okay, so we have 2x over 15. All right, here, divide. Divide means flip and multiply. So 6 over 42 is 6 times 7. I'm going to multiply that by 3 times, whoa, no, I'm not. I didn't flip it. Got to be careful. 14, which is 2 times 7. Over 3 times 3. So the 6's cross out, the 7's cross out. I'm left with 2 over 9. 3 times 3. So that would be my final answer. This is the process we'll be using, except rational expressions are have expressions. Rational expressions are multiplied using the same principles. It is usually best to cancel common factors. Factor first, then cancel common factors. Answers may be left in factored form. Okay, so we have 8a cubed b. All right, so first I'm going to note that I have a 2 here, and I can get a 2 out of the 8. I have an a to the 4 and an a cubed. Actually, let me make those different colors. It'll help it make it easier. A to the 4, a cubed. I also have a c to the 4, c squared. And I have a 25 and a 5. So I'm going to have to cancel things out of all of those. So I'm going to separate this out. So the first thing I'm going to get is I'm going to turn that 8 into 2 times 4. A cubed b 5c times c. I'm multiplying that by 5 times 5. B squared, c, 4 c's, over 2a times a cubed. I know that's a little bit of a strange way to show that. Okay, so this 2 cancels that 2. All right, let's look at the yellow. A's. I have an a cubed and an a cubed. That's why I wrote the a to the 4 as a times a cubed, so I could show you the canceling easier. All right, now I have my c's. I have 4 c's on top. I have 2 c's on the bottom, so I can cancel 2 and 2. So now I just have the 2 c's on top. Last but not least, I have my 5. We'll cancel one of the 5's in the numerator. So now I'm just looking at what I have left. I have a 4b, a 5b squared, c squared. So 4 times 5 is 20. B times b squared is b cubed. Two c's is c squared. This is over. Notice the only thing left in my denominator was the a. So this is all over a. So that would be my final value. If you had to say excluded values, I'd have to say a cannot equal 0 and c cannot equal 0. The c, because of what up here was part of my denominator. Okay. All right, so now I've got to factor these. I'm going to factor first my 5x squared minus 5x minus 100. So to do that, I'm going to have 5x and an x. X is prime. It only factors into 5 and 1. Now, factors of 100, when combined with 5, one of them is multiplied by 5, will subtract. So I have factors of 100 when combined with 5 will subtract to 5. All right, so let's see how that works. Factors of 100, well, the one I would immediately start with is 5 and 25. So 5 times 5 would be 25, minus 25, I'm going to get 0, so it can't be that. So if I were about 4 and 25, 4 times 5 is 20, and 25. There we go. So I've got, oops, I'm still in green. I've got 4 times 25 for the 100, and the 5 is 5 times 1. This gives me 20 and 25. When I subtract those, I'm going to get the 5 I want. So that means the 5 has to be multiplied by the 4, and the 1 by the 25. All right, now I have to know what signs to put in the middle. So now my largest has to be minus. The 100 is the largest. That's the 25 times, the 25 is the largest. So that means this has to be my largest. So that's a minus. Oops, wrong color. That's a minus, which makes this one a plus. All right, all of that just to factor. All right, so interesting, my eraser isn't working. Oh well, we're just going to leave it then. So this is over, I'm going to factor the denominator, 3x times x gives me 3x squared. Factors of 24 when combined with 3 subtract to 6. Well, let's see. We have 4 and 6 and 3 and 8 are our most likely. 4 and 6. Yes, that would do it, because 3 times 4 gives me 12. And if I subtract 6, I'll get 6. Okay, so 3 times 4. Now let's look at our signs. Notice this one is a plus, so that means my larger is plus, so that's my 12, which is the 3 times 4. And the 6 is minus. Okay, so now I'm multiplying this by, I can factor a 3 out of the 3x minus 6, and I have 3 times x minus 2. I apologize. Hang on, let me just write the x there. On this first term, 5x minus 25, I can factor out a 5. So what I would get, I hope my eraser works this time. How come my eraser is not working? I don't know why my eraser is not working. All right, now it's working. Okay, so what this should have been was 5 times x minus 5. Okay, same with my denominator here. These both have 3x. 3 in them, not at 3x. So this should have been 3 times x minus, it was a 6, so x minus 2. All right, my apologies. All right, so now, notice I have x plus 4, I have x minus 2, I have 3. So what I am left with is 5 times x minus 5 over x. Excluded values, I can't have x cannot equal 0. You can see that at the end. Also, notice in my original denominator, I can't have x equal 2 or negative 4. So those would be my 3 excluded values. All right, the division of rational expression follows the same principles used for dividing fractions. You multiply the dividend by the reciprocal of the divisor. A lot of words. Flip and multiply. When the numerator or the denominator of a fraction contains a rational expression, the entire fraction is called a complex rational expression. So, we're going to flip and multiply, but in the process we have to divide. All right, I stepped all over it last time. I'm going to factor first. That's what I'm supposed to do. So I can pull a 6 out of this first one, and I get x squared plus 8x. Oh, this is not writing well. Plus 26. No, not 26, 31. No, I was right. Good grief. 26. Okay, I'm going to grab my calculator to be sure. All right. I've got 96 divided by 6. Yeah, oh, nope, see? I was way off. It's 16. Jiminy crickets. 16. This is over. I can pull out a 2. X squared plus 4x minus 5. Now I'm going to multiply, so I'm going to flip these two to do that. I can pull a 10 out of the top one, and it leaves me with x squared plus 8x plus 15. And but in the new denominator, I can pull a 5 out. I have x squared plus 2x minus 8. All right. Isn't this fun? We're having so much fun. Okay, now we have to factor all 4 of these quadratics. So this is going to become 6x, x. Factors of 16 that add to 8 are 4 and 4. They're both pluses. Okay. And then I have factors, my denominator. Okay, factors of 5 that subtract to 4 are going to be 5 and 1. The larger is plus. Okay, I'm going to multiply this by, I'm going to write the 10 as 2 times 5, since that's what I have in my denominator, because this is going to have a 5 in it. All right, x squared plus 8x plus 15. This means factors of 15 that add to 8, so that's 5 and 3. They're adding, so it's all pluses. They're the same and they're pluses. All right, x squared plus 2x minus 8. I have x, and I need factors of 8 that subtract to 2. That's 4 and 2. The larger has to be plus, so it's an x plus 4 and an x minus 2. Now I can simplify this, by crossing things out. All right, x plus 4, x plus 4, x plus 5. All right, 5 and 2. Okay, so what am I left? I am left with 6 x plus 4 x plus 3 over, no constants, but x minus 1, x minus 2. And that's my final answer. X cannot equal -5, 1, -4, or 2. Okay, moving on. This one, there we go. Simplify, stating any excluded values. Okay, this is a division again. So we're going to flip and multiply. So we have flipped this term, the denominator, and made it a multiplication. Now I can factor x squared minus 3, x squared minus 9 into conjugates x minus 3, x plus 3. And this denominator I can factor into x minus 3, x plus 2. Yep. Okay, now I can start crossing all kinds of fun things out. Let's say I have an x minus 3, I have an x plus 3, and I'm left with the ever so simple 1 over x plus 2. And that would be my final answer. Excluded values. Well, because of that, x cannot equal plus or minus 3. Because of this denominator, x cannot equal 2. Nope, -2. Yes, those are all my problems. All right. And then we're done, so enjoy your homework.